How about at the after party? You and all your friends say they love to get naughty. Sipping on that hit, I know you love that Bacardi. 1942, I take you back in the raw. Okay, I pull up. How about at the...
Hello there! Are you here to learn how to make fun, exciting robots? Maybe even pick a few tricks up along the way? Then this is definitely the video for you! Here's more on us. We're a group of 3 people, comprising of Adam, Ryan, and me, your narrator, Hari. We're here to show you how we started from a pair of hobby motors to a finished robot. Enjoy. First up, movement. To maneuver the thick wilderness that is EG1311, you must be resilient and not shy away from the adversities that lie in your path. Fear not, this educational video was rated a 10 out of 10 by all our peers and will equip you with the necessary tools. We built everything off of the simple wheel. From the beginning, it was decided that the radius of the wheels had to be bigger than the bump to cross over it. However, there were some limitations that made us not consider printing this design. Referring to the template project, the wheels were not much bigger than the bump, making it difficult to cross over. Second, due to the rough nature of cardboard, the movement was irregular and bumpy, causing the robot to deviate from its path. Our next idea was a wheel with grooves. This would help the robot hook onto the bump, pushing the robot over. While this prototype was mostly a success, the lack of friction was still a problem. We also added the anti-slip mat as a countermeasure, but the robot eventually succumbed to its instability.
Brother, think you're
Oh my! How will we find our way through? We need to figure out which path is safe to take through the jungle. Look! There's a green path, verde, a red path, rojo, and a yellow path, amarillo.
The yellow path!
The yellow path, amarillo. Do you see the frog?
Right there!
There it is!
Come on!
So we go this way.
Muchas gracias, Dora. Due to the adhesive nature of double tape, the increase in friction provided the means for our robot to move past the bump and climb the ramp with relative ease. We think this is something unique within our tutorial, since most either used an additional hard material or went with the ice cream stick approach. Next on our list was the body of our all-terrain vehicle. The design for this element was simple. The only constraint was that it needed to accommodate our Arduino Uno, breadboard, 9-volt battery, ultrasonic sensor, and lastly our catapult. We did not face much difficulty with this element and settled on foam core since it was firmer and we were able to hot glue the motors on it easily. As a side note, to reduce weight, our usage of 3 motors led to the creation of a tail for the support of the rear motor. Our catapult consisted of 2 columns that supported the servo motor itself, arm, and cradle. Our early iterations were limited due to the improper length of the arm and cradles that were sized too big. After corrections to the dimensions, we also realized that a change in the initial angle of the arm with respect to the servo motor would also help keep the ball within the cradle. In the end, our final design managed to fit within the legal dimensions, just by a margin. And lastly, our graded run. Making this video was a labor of love, and we thank you for watching.